Hey everybody, it's Mr. Jacob here from the Turner Community Library at the Kansas City, Kansas Public Library System. And I am back with more science experiments. So, this science experiment kit is for water science. So, by now you should have picked up one of our kits. Looks just like this. Let me move the flashlight. There we go. And in the kit, when we open it up, you're going to have our introduction that explains everything, explains when the class is and all that. A list of supplies you need that are not included. Unfortunately, we couldn't buy everybody measuring cups or flashlights or anything like that. So you will need to make sure to get these. You also have 4 experiments in here. We've got the hard water experiment. We've got the dancing colors experiment. We have the make a rainbow experiment. And then we have the water cycle experiment. One thing I'd like to note about these kits. On the dancing color one, there's vegetable oil in here. You'll notice there's 2 bags. I had problems with some of them spilling. They leaked out. So I put them in 2 bags. If your kit still leaked out, everything should be easy to clean. You'll just have to get a little bit more vegetable oil. You'll just need a little bit. So as you watch the video, you'll find out how much to use. But if it did leak out, I'm very sorry. I did my best. So let me put this back, and then we will begin. So go ahead and get all of your experiments set out. By the way, this is going to be a messy one, so you might want to wear clothes that are appropriate for this. Okay, you guys ready? All right, so the first experiment we're going to do is we're going to make a rainbow. So if you want to get that kit out, which basically is this thing, and you're going to need a glass of water. By the way, you will get cups. You want a see-through glass. Now, this one's plastic. I tested it. It works. You probably want an actual glass. Some of our plastic cups you couldn't really see very well through. So you can try one of these if you have one of the really clear ones, or just find very clear glass that'll fit this. And I've got the tape on here just so nobody cuts themselves on the sharp edges. Now, you will also need a flashlight. We are going to put this in the water. And we're going to turn on the flashlight and shine it on that. And we're going to try to create a rainbow. Now to do this, I'm going to have to turn off the lights. All right, let's give it a shot. And I can see some rainbow. I don't know if you guys can see it. There we go. So you might just be seeing light. I'm not sure. But if you do this, you point the flashlight at the CD and you can move it around. And if you hit just the right spot, you'll see it makes rainbow. Okay, so while you're doing that, I'm going to explain what is happening here, why we're getting a rainbow when we do this. So basically, this is the same thing as when you see a rainbow in the sky. It shares the same kind of characteristics of colors and order. So in both cases, they share the same principles, the same thing's happening. It's refraction and reflection. So refraction is how light bends when it passes through different things, like glasses or water. How the light bends is refraction. Then when we shine a white light into the water, that light bends. But it isn't just white light that's going in there. The white light isn't one color, I should say. The white light is actually several colors. It's a combination of all visible colors. A white light is made up of red, orange, yellow, green, blue, and indigo. When you put the flashlight on there, it actually breaks up all of those colors. Each light bends at a different angle. Basically, each color is traveling at a different speed inside the water and the glass, and that's why you can see them. And when you see a rainbow, it's the same thing. So it's just taking that white light and breaking it into its individual colors at different speeds, and it makes them easy to see. Now, when you reflect the light back out of the water using the mirror, you're reflecting the white light that's been broken up into these colors. So by putting the light through the water and through the glass, you're refracting. And then when it hits the mirror, or in this case the CD, it's reflecting it back out. And that's what lets us see the rainbow. So that is the Make a Rainbow experiment. Okay, go ahead and set that aside. Keep your glass aside if you need to use it just in case. Now, the next one we're going to do is water cycles. And this one is going to be one of those things where you're going to have to do a lot of this on your own. I can't really show you exactly. I'm going to explain how this works. But you're going to have a bag in there. And what I want you to do is you have a bag and a Sharpie. I want you to draw all of this onto there. And there's a picture included so you can see. What we're going to do here is we're going to show how water cycles. Now, a water cycle is basically known as hydraulic cycle, and it describes how the water moves continuously on Earth. So water loops through different stages. It loops through evaporation, right there. It loops through condensation, precipitation, and flow. So it goes, and then once it does all this, it goes right back into the evaporation stage. So it's just a big cycle. And the whole cycle starts over and over again, and that is called the water cycle. So what I want you to do is you're going to warm up some water with a parent or an adult until you see steam start to rise, but you do not want it to boil. So you just want the water hot enough that you can see steam off of it. And if you want, add some blue food coloring. That can be your ocean, or you can just put the water in. That's just for fun. And you're going to put some water in a Ziploc bag, maybe about right to here. So you don't want to fill this up. You just want it just enough about right there. So where your ground is and your sea is. Then you're going to get some tape, probably some duct tape or some really strong packing tape. And you're going to hang this up in a window. Or you can put it in a door. And then that way it can get to the sun and get heat and all that stuff. As the water evaporates, you're going to see vapor rise and condense at the top of the bag. So it's going to come all the way up here to the very top. And you'll see a white patch that will kind of look like clouds up here. That's basically the atmosphere. And then after a while, you'll soon start to see water droplets start showing up in the bag. And as they get bigger, they'll start sliding down the bag down to the bottom. And that resembles the flow stage that brings the water back into the sea. And that's what will just keep happening is this water will evaporate. It'll come up to the top of the bag. It'll start condensation, start coming down again, and it'll just keep going. There's a neat experiment we did in school one time where we were doing like rainforest, and you take a soda bottle and you put a plant in there and put the dirt in there and then put the clear part of the soda bottle on top and you trap it together and it would just water itself. And this is kind of like the same idea. So this is a really neat experiment to try, and if you want to try the other one, I can look into doing that in the future. But that is the water cycle experiment. And please let us know how it turns out for you guys, okay? Let's move on to the third experiment. I'm going to give you a second to set up, but we are going to need the vegetable oil. This one is called, the dancing colors. This is the dancing colors. Now, this is the one where if your vegetable oil leaked out of the bag, I'm very sorry. You'll just need a little bit. You see, we get about this much. We just need to put about ½ an inch at the bottom of a cup. So get a cup. Put your vegetable oil inside. So you have about ½ an inch. There we go. Now you'll need food coloring. And what you're going to do is put a few drops in there. Don't go too crazy. So I'm going to put one of that one. That's pink. That's blue. I'll probably just do one more. There we go. Now you'll see you also have a stick. If you pick this up, you see they're kind of blobs right now. If you just put your stick in there and then kind of stir it back and forth, you'll actually break up those blobs and they become tiny blobs. So I want you to do this. Do not mix the colors together. So try to keep your blobs in separate areas. But if you do this, you can just make all these little tiny little blobs. Now, the next thing you need is a cup of water. I'm going to use the water we had from before. And you're going to pour the water on top. Or I'm sorry, not the water, I'm sorry, the oil. Pour the oil on top. And then we're going to watch what happens. Okay, now as we watch this, you can start seeing some of the colors go down, and they are spreading out. That was a good one. And you can try this with a lot if you want, or you can try it with different ones, different amounts. But basically, what is happening here is baby oil and water don't mix. That's insoluble. It's insolubility. So when you pour the oil into the water, it sinks into the water because of gravity and the momentum, how fast I poured it in. But instead of mixing with the water, the oil forms a bubble, and that bubble eventually goes back to the top. So these two liquids won't mix together because the oil is made up of non-polar molecules, and the water is highly polar molecules. I know those are a lot of words, but basically they're two different things. And the oil is soluble in water. And the oil, it also has a different density. So it has a lower density than the water. And that lower density, it makes it float on top of the higher density fluid, which is the water. So the food coloring also has a higher density than the oil. So when you put all these things together, the food coloring stays up while the oil stays up for a little while, and eventually it will all sink below the oil and dissolve into the water because the food coloring is soluble. So that's why the food coloring eventually drops through and hits the water and then just starts doing this and makes all these fun little rainbow colors. And this is a process with the food coloring and the water. That's a process called diffusion. So it means that the molecules are moving from a region of high concentration to a region of low concentration. So remember, the oil is like the high concentration. So the concentration of the coloring is the highest when it was in the oil layer. Then it started moving towards the water where it was lower. So in enough time, all this will mix together and it'll become a nice little muddy color. But that is diffusion, and that is the dancing water. Let's get ready for our last experiment. We are going to make solid water. Now, in your bag, you'll find something that has cornstarch right here, which I've already put in this cup. And you're going to have a spoon, and you're going to have this cup with a line on it. I want you to fill this up to the line with water. And then I'll give you a second, and when we're ready, we'll get started. Okay, are you guys ready? Go ahead and pour the water in there and start stirring up the cornstarch and the water together. Now as you stir, it's going to get harder and harder to stir. It's going to get chunky. And when it does that, go ahead, pour it in your hand. I'm going to leave that sitting there for a second. You can see it's pouring off the side too. I still have cornstarch. There we go. That's okay. I didn't mix it all, but that's all right. We got enough. So, take this, you tap it, or you can crunch it, and you feel how hard it becomes. But then, after you do all that, let go. And then watch what happens. So as we're waiting, I'm going to explain what's happening here. So basically, cornstarch with water is a type of mixture called a colloid. When you put your finger through the water, it does something called sideways shearing force. That's basically the way water shears or moves out of the way. So you put your finger in there and it moves out of the way. The cornstarch acts this because of its viscosity or resistance to flow. So it, while your finger can go through the water and the water moves out of the way, this doesn't want to move out of the way. It's like, no, I ain't going to do that. I'm going to stay where I want to stay. So the water's viscosity doesn't change when it is sheared, but the cornstarch mix does. So this starts becoming more of a liquid again after a little bit. You can see it's kind of wet there. So normal liquids like water are called Newtonian fluids, but this is called a non-Newtonian fluid. And there are other non-Newtonian fluids, which are things like ketchup and quicksand. So you can see this is kind of a liquid. It's starting to pour down the sides of my finger. But if I start pushing on it, it gets hard. So it even flakes. But if I let it go, it starts returning back into a kind of a liquid. Now, if yours is too wet, you might have too much water in it, so you might just add a little bit more cornstarch. Or if it doesn't do enough, like I didn't have quite enough water in here, otherwise all this would have been in there, you can add a little bit more water and just kind of play with it. But that is solid water. And you can do a bunch of different experiments with this. Like you can make a batch of this, find an old speaker, like from a stereo, turn it upside down, put it on top of the speaker, and then play music really loud and watch what it does. Because you will see this stuff dancing up in the air. So it's really cool. Be sure to do that with permission from a parent, though. Okay? So thank you guys for watching. This is a brand new experiment for me, and I'm just happy to be able to show you guys how to do this. So I hope you enjoyed it, and I hope you guys check out some of our future stuff. We have a lot more homeschool things coming up and a lot of other programs. So thank you guys, and we'll see you again later. Bye.